हम्म, बिस्मिल्लाहिर्रहमानिर्रहीम। आज के लेक्चर में हम कुछ न्यूमेरिकल प्रॉब्लम सॉल्व करेंगे दैट इज़ रिलेटेड टू इंडक्शन मोटर. So we have an example that we have a three-phase 50 hertz induction motor and it has 8 poles. It runs at a speed of 700 rpm. We have to find the synchronous speed, we have to find the slip, we have to find the rotor frequency at the time of starting, and we have to calculate the rotor frequency at the given speed. So first of all we have to write all the given information. So given data, we have frequency. So this machine is operating on 50 hertz. The number of poles are 8, so P is the number of poles, and we have the rotor speed is 700 rpm. We have to find required. So we have to find what? The synchronous speed. We have to find the slip. We have to find the rotor frequency. At the time of starting, the slip is 1. When slip is equal to 1, and we have to find the rotor frequency at given speed. So now let's come toward the solution. First of all, we have to find about the synchronous speed. So the synchronous speed is actually 120 f divided by p. So that is 120 f is 50 hertz and number of poles are 8. So the synchronous speed comes out to be 750 rpm. Now we have to find about the slip. So the slip is actually it is the difference. Person slip is actually n synchronous minus n rotor divided by n synchronous. So we calculate the synchronous speed comes out to be 750. The rotor speed is given as 700 rpm. So calculating this, we will get the person slip as 6.6%. We have to multiply this to with 100 in order to get the person slip. So now we are also we have to also find the rotor frequency in part C. We have to find the rotor frequency when at starting condition. So at the time of starting, we know that the slip is 1 because the rotor speed is 0, and when synchronous speed divided by synchronous speed comes out to be 1. So at the time of starting, the slip is 1. So the rotor frequency is equal to slip time the stator frequency. So as the rotor slip is 1, so the rotor frequency is equal to what? The stator frequency, that is actually 50 hertz. Now in part D, we have to find the rotor frequency at the given speed when the rotor is running at 700 rpm. So when the rotor is running at 700 rpm, so the slips comes out to be 6.6%. So the rotor speed, the rotor electrical frequency is equal to slip time the stator electrical frequency. This is 0.066 into stator electrical frequency is actually 50 hertz. So when you multiply both, so this comes out to be 3.3 hertz. So this is actually the rotor frequency.